Greetings, I am Kenneth Brown, a first-year mechanical engineering student.
I am Dejah Reed, a second-year pre-med biology student.
And I am Elon, a first-year pre-pharmacy student. And today we are here to talk about Chapter 4.1, Extreme Values of Functions. Maximum and minimum values are called extreme values of the function f. Absolute maxima or minima are also referred to as global maxima or minima. Extreme values of a function consist of multiple components. The maximum and minimum points are broken down into absolute minimum and maximum.
Well, you can see here on the function that we drew, this crazy function here, you have an absolute maximum here and an absolute minimum here. These basically represent the points on the function where it's at its highest and at its lowest points.
Theorem 1, the extreme value theorem, states that if f is continuous on a closed interval of a and b, then f attains both an absolute maximum value m, capital M, and an absolute minimum value of lowercase m on the interval of a and b. That is, there are numbers x1 and x2 in the interval a and b with f x of 1 equals m and f x of 2 equals capital M, and m is less than or equal to the function and less than equal to the function of m for every other x in a and b.
For our second example, we have f of x equals x squared. So on this function here, we have an absolute maximum at y equals 4 and an absolute minimum at y equals 0.
Local maximum or minimum values and points are the same as the absolute, besides it being the maximum or minimum in a certain interval on the graph or interval of the function f. These local extrema may also be referred to as relative extrema.
Back to picture 1 of our original function, we've used this rectangle to basically show an interval. So we labeled our local maximum and our local minimum. These points are the highest and lowest points within a closed interval.
Theorem 2 states that has a local maximum or minimum value at an interior point C of its domain, and if f prime is defined at C, then f prime of C is equal to 0.
So back to our second function, f of x equals x squared, we now have an interval where it's closed. So since we put an interval on this, imagine this as a snippet from a larger function. So with this, we will now have a relative or local maximum at y equals 4 here, and a local or relative minimum value at y equals 0.
The only place where a function f can possibly have an extreme value, whether local or global, are at 1. Interior points where f prime is equal to 0, f prime is undefined, or at the endpoints of the domain of f.
So here are some examples of having an endpoint where it can be your absolute maximum and absolute minimum. So here you have neither an absolute maximum or minimum. But if you were to change this here, you have an interior maximum here and a absolute minimum at the endpoint. But if you were to change the graph like this, you will have two interior points or two interior critical points with a maximum here and a minimum here.
An interior point of the domain of a function f where f prime is 0 or undefined is a critical point. Most problems that ask for extreme values call for finding the extrema of a continuous function on a closed infinite interval.
So to find a critical point, you need to find the derivative of a function where it equals 0 or is undefined. So for an example, we're using f of x equals 3x cubed minus 9x plus 3. So we're going to start by finding the derivative of this function. So f prime of x is equal to 9x squared minus 9 equals 0. So now that we have this, we're going to solve for x. So we're going to have the 9x squared equals 9, x squared equals 1, x equals plus or minus 1.
1.
So now we're going to use a sign chart to show that it's a change from positive to negative at these critical points. So you're going to have a number line with -1 and 1, and we know that when it's less than -1, it's going to be positive. When it's in the middle of -1 and 1, which we chose 0, is going to be negative. And when you have a number larger than 1, which we chose 2, is going to be positive once you plug it back into your function f prime of x. So with that, you see that it changes at -1 at their critical points from positive to negative back to positive. And that concludes our examination of 4.1, finding the extreme values of functions. Thank you.